hello everyone. So today I am going to discuss one important chapter, that is Introduction to 3D Geometry. Actually chapter का नाम है 3D Geometry. So today I am going to discuss just the introduction part. ये चैप्टर शुरू करने से पहले मैं बताना चाहता हूँ कि ये चैप्टर बहुत important है. Actually वेक्टर अलजेब्रा एंड 3 डायमेंशनल ज्योमेट्री, ये दो चैप्टर से 16 मार्क्स कैरी करता है. ओके, इन CBSE 16, whereas in council 17 marks. तो ये चैप्टर बहुत इंपॉर्टेंट है, वेक्टर एंड 3D ज्योमेट्री. ओके, इवन इन एंट्रेंस एग्जाम ऑल्सो फ्रॉम वेक्टर it will carry two or three questions, whereas in 2 dimensional geometry and 3 dimensional geometry को मिला के 4 to 5 questions carry हो जाता है. ठीक है, so बहुत important है for board purpose as well as for entrance exams. Okay, so that's why today I will discuss only the introduction part, that is the basic things. Already you got in class 11. Okay, already you got in class 11, but again I am repeating those things only. Okay, I will repeat all those things, that is the basic things. So first of all, पहले क्या जानना पड़ेगा geometry 3D geometry के बारे में. It is difficult to draw in board the 3 dimensional. अगर ये 2 dimensional geometry होता तो प्रॉब्लम नहीं था, like x and y axis. लेकिन 3 dimensional geometry में क्या होता है? There will be 3 axes, right? X, y, z axis. So it is difficult, it will be difficult to explain in board, but you just imagine it. Okay. So first of all, you have to understand the coordinate axis. Axis is the plural sense of axis. Okay, there are 3 axes, x, y and z axis. So coordinate axis and coordinate planes in 3-dimensional geometry. First subtopic is coordinate axis and coordinate planes in 3-dimensional geometry. So you see this figure, x o x dash, y o y dash and z o z dash. These are what? These 3 are mutually perpendicular lines or not? X o x dash, y o y dash, z o z dash. These are 3 mutually perpendicular lines intersect at origin O. Yes or not? Okay. Now these 3, that is x o x, y o y and z o z dash, x o x dash, y o y dash and z o z dash, these 3 lines represent x axis, y axis and z axis respectively. मैं बहुत स्लो जाऊंगा ये चैप्टर में, हाँ थोड़ा सा समझना है, ये थोड़ा सा डिफिकल्ट है एक्चुअली. सो x o x dash, y o y dash, z o z dash, these 3 lines are called, these 3 mutually perpendicular lines are called x axis, y axis and z axis respectively. Okay, now these 3 mutually perpendicular lines, which 3 mutually perpendicular lines? X o x dash, y o y dash and z o z dash. These 3 mutually perpendicular lines defines 3 planes. And what are those 3 planes? X O Y plane, Y O Z plane, Z O X plane. These 3 mutually perpendicular lines, that is X O X dash, Y O Y dash, Z O Z dash, these 3 mutually perpendicular lines divides or defines 3 planes. What are these 3 planes? X O Y plane. This X O Y plane you can say X Y plane also. Y O Z plane you can say Y Z plane. Z O X plane you can say Z X plane also. ठीक है, X O Y के जगह में अगर X Y plane भी लिखना है तो कोई प्रॉब्लम नहीं है. Y O Z के जगह में अगर Y Z plane लिखोगे तो भी कोई प्रॉब्लम नहीं है. Z O X plane के जगह में अगर Z X plane लिखोगे तो भी कोई प्रॉब्लम नहीं है. राइट, नाउ these 3 planes, what are these 3 planes? X Y plane, Y Z plane and Z X plane. These 3 planes divide these space into 8 parts. जैसे if it is a 2D geometry, then we can say that the xy plane divides into 4 parts. Yes, first quadrant, second quadrant, third quadrant, fourth quadrant, right? In case of 3D geometry, the 3 planes, there are 3 planes. अभी तो पता चल गया क्या क्या है वो 3 planes, xy plane, yz plane, zx plane. These 3 planes divide these space into 8 parts. These are called octants. Of course, chemistry में भी मिला 8 means octant बोलते हैं. Okay, 4 means quadrant. In case of xy, in case of 2D geometry, it divides into 4 parts. So that's why it is called quadrants. Yes, first quadrant, second quadrant, third quadrant, fourth quadrant. In case of 3D geometry, it divides into, these 3 planes divide into 8 parts. These are called octants. Okay, so this is all about the figure. ये figure के बारे में details में बता दिया. ठीक है, क्या क्या है? xo x dash, xo x dash, yo y dash, and zo z dash. These 3 are what? Mutually perpendicular lines intersect at what? At origin. xo x dash is called x axis, yo y dash is called y axis, whereas zo z dash is called z axis. Yes, these 3 mutually perpendicular lines divides or defines 3 planes. What are these 3 planes? xy plane, yz plane, and zx plane. These 3 planes divide the space into 8 parts. These are called what? Octants. First octant, second octant, third octant, fourth octant, fifth octant, sixth octant, seventh octant, eighth octant. Right? Now, from the figure, now we can say the equations. अभी ये figure से equations कैसे find करें? देखो, equation of yz plane. Equation of yz plane. This is yz plane. कैसे याद रखना है? देखो, yz plane में x का कोई connection नहीं है, because x is far away from yz, right? X is far away from yz plane. So that's why the equation of yz plane is x equal to 0. जो point और जो axis वो plane से दूर में रहता है, that is equal to 0 लिखना है. That's it. Similarly, equation of zx plane. This is zx plane. This part मैं arrow mark देके explain कर दिया. This is zx plane. ये जो complete part है ये zx plane है. Okay, z और x. Yes, there is no connection between these two planes, that is y axis. So zx plane में y का कोई connection नहीं है. Y तो यहाँ पे है, so it is far away from zx plane. So that's why equation of zx plane is y is equal to 0. Similarly, equation of xy plane. This is xy plane. This is xy plane. Arrow mark देके मैं represent किया. This part is called xy plane. Since this part is called xy plane and there is no connection with z axis, so that means the equation of xy plane is z equal to 0. Okay, ये सब कुछ याद रखना पड़ेगा, इसीलिए मैं पहले थोड़ा सा इंट्रोडक्शन दे रहा हूँ. ऐसा ऑलरेडी क्लास 11 में मिल गया था, फिर एक बार मैं रिकॉल कर रहा हूँ सब. ठीक है, थोड़ा सा समरी जैसा, समरी टाइप. So equation of yz plane is x equal to 0. Equation of zx plane is y equal to 0. And equation of xy plane is z equal to 0. ठीक है. So this is all about your coordinate axes and coordinate planes in 3D geometry. So coordinate plane is, there are 3 planes. Yes, x, y, y, z and zx plane. And these 3 zx planes divide the space into 8 parts, are called octants. Okay. So next point, next part is coordinates of a point in space. यहाँ पे भी और एक मैं डायग्राम दे दिया. Coordinates of a point in space. एक स्पेस में से कैसे कोऑर्डिनेट्स फाइंड आउट करना है वो अभी मैं एक्सप्लेन करूंगा. So this is also one figure. फिगर के बारे में मैं बाद में जाऊंगा, एक एक करके स्टेप बाय स्टेप में जाऊंगा. ओके, यहाँ पे मैं क्या लिखा? द कोऑर्डिनेट्स ऑफ ए पॉइंट आर द डिस्टेंसेस फ्रॉम द ओरिजिन टू द फीट ऑफ द परपेंडिकुलर्स फ्रॉम द पॉइंट ऑन द रिस्पेक्टिव कोऑर्डिनेट एक्सेस. वंस अगेन आई एम रिपीटिंग, ये एक बार पढ़ने के बाद मैं फिगर में जाऊंगा. ठीक है, द कोऑर्डिनेट्स ऑफ ए पॉइंट आर द डिस्टेंसेस फ्रॉम वेयर टू वेयर, are the distances from the origin. This is origin whose coordinates are 0, 0, 0 to the feet of the perpendicular from the point on the respective coordinate axis. अभी देखो. Here O is the origin and we know the coordinates of O are 0, 0, 0. Here also 3 axes are there. Axis means the plural sense of axis. 3 axes are what? X, Y and Z axis. Yes? Here also 3 axes are there. That is X axis, Y axis and Z axis. Right? Okay. We know any point on X axis. First of all, see, let us consider there is one point in the space P whose coordinate X, Y, Z. Yes? Let us consider there is a point P in the space whose coordinate X, Y, Z. Now, any point on X axis, this is X axis, yes, distance from origin O to the feet of the perpendicular from the point on the respective coordinates. So, origin O, यहाँ से इसका distance देखो. A lies on which axis? The point A lies on X axis. So any point lies on X axis, the coordinates of that point will be X, 0, 0 because यहाँ पे Y और Z का कोई कनेक्शन नहीं है. ठीक है. So जैसे 2-dimensional geometry में क्या होता है? This is X axis. If I say there is a point on X axis, तो इसका coordinate क्या होगा? X, 0. Yes or not? So in case of 3D geometry क्या हो जाएगा? और एक axis add हो जाएगा ना? X, Y and Z axis. So any point on X axis, the coordinates of any point on X axis are X, 0, 0. Similarly, the coordinates of any point on Y axis, here B lies on Y axis. The coordinates of any point on Y axis 0, Y, 0. Similarly, the coordinates of any point on Z axis are 0, 0, Z. Yes? Now, ये तो हो गया when the points lies on X, Y and Z axis. But if the point lies on the plane, how many planes are there? यहाँ पे already मैं बता दिया, there are 3 planes, X, Y, Y, Z and Z plane. X, Y, Y, Z and Z X plane. So if any point lies on X, Y plane, suppose this is X, Y plane, this part is X, Y plane, यहाँ पे जो नीचे शेड किया गया, this is X, Y plane. Which point lies on X, Y plane? Whether A or B or C dash. Which point lies on X, Y plane here? We can say that A lies on X axis, B lies on Y axis. The point C dash lies on XY plane. So any point, the coordinates of any point lies on XY plane are X, Y, 0 because there is no connection with Z axis. इसीलिए तो देखो XY प्लेन का इक्वेशन क्या होता है हमेशा? XY प्लेन का इक्वेशन हमेशा 0 होता है, Z equal to 0 होता है. So any point, the coordinates of any point lies on XY plane are X, Y, 0. जो एक्सिस दूर में है उसका कोऑर्डिनेट हमेशा 0 होता है, ऐसे याद रखना है. Similarly, in YZ plane, which point is there? A dash. Yes. So therefore, the coordinates of A dash lies in YZ plane are 0, Y, Z because यहाँ पे X का कोई कनेक्शन नहीं है, X तो बाहर में है. Okay. Like this only, the coordinates of B dash, here B dash lies on which plane? ZX plane. तो अगर ZX plane में है तो Y 0 होगा, X, 0, 0. पोजीशन में लिखना पड़ेगा. ठीक है, पोजीशन में लिखना है. पोजीशन का मतलब यहाँ पे 0 बीच में ही होगा बिकॉज Y बीच में आएगा. X के बाद नेक्स्ट अल्फाबेटिकली Y आता है, नेक्स्ट Z आता है. ऐसा अगर यहाँ पे X, if you write X, Z, 0, then this will be wrong. Okay, अल्फाबेटिकली क्या आता है? X के बाद नेक्स्ट Y आता है, नॉट Z. तो इसीलिए जिसका जहां पे पोजीशन है वैसे ही लिखना पड़ेगा. Since B dash lies on ZX plane, so that's why Y coordinate 0. तो Y तो हमेशा X और Z के बीच में होता है, इसीलिए बीच में ही 0 लिखना पड़ेगा. Okay, so this is all about coordinates of a point in space. क्या बोला मैं फिर से एक बार रिपीट कर रहा हूं. Let us consider P of X, Y, Z be any point in the space. Then we can find the coordinates of these points A, B, C, A dash, B dash, C dash. ठीक है? Here A dash, B dash, C dash lies on particular planes, whereas A, B, C lies on particular axis. Okay? So this is all about coordinates of a point in space. कैसे coordinates find out करना है? यहाँ पे मैं equation के बारे में बता दिया, यहाँ पे coordinates के बारे में बता दिया. Okay? Now there are some useful results. There are some useful results. Already ये सब भी मिल गया था. Result number 1. Distance between the 2 points. Distance formula. Distance between the 2 points. जो 2 dimensional geometry में मिला था वो तो सबको पता है. So distance between the two points in case of 3D geometry. Let P of x1, y1, z1 and Q of x2, y2, z2 be the 2 points. Then the distance between them is given by under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is the distance formula. Distance between the two points in case of 3-dimensional geometry. Okay. Number 2. Midpoint formula. The midpoint of a line segment. The midpoint of a line segment joining P of x1, y1, z1 and Q of x2, y2, z2 is x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. The midpoint of a line segment joining the points P and Q. Coordinates of the midpoint. Okay, x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2 in case of 3-dimensional geometry. Number 3. Centroid formula. Centroid of triangle ABC. Let us consider the vertices be A, B and C whose coordinates are x1, y1, z1, x2, y2, z2 and x3, y3, z3. Okay. Then we know centroid is denoted by G. So G is equal to coordinates of G. कैसे find out करना है? x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. Okay. So ये हो गया centroid का formula. Centroid is denoted by G. Okay. Next will come section formula. ये सब मैं summary type दे रहा हूँ because already you got in the last class, in class 11, you got all these formulas. Okay. So next will come section formula. Number 4, section formula. There are 2 types of formula. One is internal section formula, another one is external. So internal क्या होता है? Let us consider a line segment joining the points P and Q whose coordinates are also given x2, y2, z, x1, y1, z1, x2, y2, z2. Let the point R whose coordinates suppose x, y, z. Let the point R divides PQ in the ratio m is to n. Let the point R divides PQ in the ratio m is to n internally. Therefore, R is equal to, we can write mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, mz2 plus nz1 by m plus n. ये हो गया इंटरनली सेक्शन फॉर्मूला. जो नॉर्मल सेक्शन फॉर्मूला है उसके जैसा ये और एक एक्स्ट्रा कोऑर्डिनेट आ जाता है, दैट इज z कोऑर्डिनेट. ओके. सो ये हो गया इंटरनल सेक्शन फॉर्मूला। अभी एक्सटर्नली क्या होगा? एक्सटर्नली मतलब दिस इज P, दिस इज Q. सपोज देयर इज ए पॉइंट R which divides PQ externally in the ratio m:n. मतलब R जो है वो बाहर से डिवाइड किया PQ को इन द रेशियो m:n. Then the coordinates of R, because since R divides PQ, so therefore coordinates of R will be mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n, mz2 minus nz1 by m minus n. ओके ज्यादा कुछ डिफरेंस नहीं है। इंटरनली में प्लस साइन होता है और एक्सटर्नली में माइनस साइन। ये एक्सटर्नली सेक्शन फॉर्मूला है। ओके व्हेन द पॉइंट R डिवाइड्स फ्रॉम द आउटसाइड in the ratio m:n, then you have to use minus sign. If the point R divides PQ in the ratio m:n internally, जब R बीच में रहेगा, then you have to use plus sign. Okay, so distance formula, midpoint formula, centroid, section formula, ये सब basic formulas है, right? So some more topics are there. Some topics I will discuss in the next class. So the next topics are direction cosines. Already I have discussed in vector algebra about direction cosines of a line and direction ratios. Okay, since all these things again we need in 3D geometry, that is 3-dimensional geometry. So I want to give the introduction, the summary part. Okay, so direction cosines. Direction cosine क्या है actually? This is origin, y-axis, z-axis, this is x-axis. Suppose there is a line L. फिर से मैं एक बार थोड़ा सा summary type दे देता हूँ. Suppose there is a line L which is passing through the origin, and this line makes an angle alpha with x-axis. This line makes an angle alpha with x-axis, beta with y-axis, and gamma with z-axis. Okay, there is a line L which is passing through the origin and makes angles alpha with x-axis, beta with y-axis, and gamma with z-axis. So these angles, that means alpha, beta, and gamma, these angles are called what? Directed angles. Okay, these angles are called directed angles. And the cosine of these angles, that is cos alpha, cos beta, and cos gamma, the cosine of these angles are called direction cosines. Okay, alpha, beta, and gamma are called directed angles, whereas the cosine of these angles, that is cos alpha, cos beta, and cos gamma, are called direction cosines. Okay, and generally direction cosines are denoted by LMN. So we can say L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. Direction cosines are denoted by LMN. Okay, so L equal to cos alpha, M equal to cos beta, N is equal to cos gamma. All these things I have explained in vector algebra. Okay, one more time I am repeating all these things. Okay, so this is all about your direction cosines. Whenever a line L which is passing through the origin makes an angle alpha with x-axis, beta with y-axis, and gamma with the z-axis, these angles are called directed angles, whereas the cosine of these angles are called direction cosines. Okay, L equal to cos alpha, M equal to cos beta, N is equal to cos gamma. So this is all about direction cosines. Next will come the relation between the direction cosines of a line. Relation क्या है? Relation, since direction cosines are denoted by LMN, so the relation between the direction cosines of a line is L square plus M square plus N square is equal to 1. इसका derivation भी मैं दे दिया था वेक्टर अलजेब्रा में. ठीक है, I will not discuss the derivation part again. Okay, just I have given the relation. The second point is the relation between the direction cosines of a line. Since the direction cosines are denoted by L, M and N, so the relation is L square plus M square plus N square is equal to 1. Very, very important relation. Okay. Next, point number 3 is direction cosines of a line passing through 2 points. अच्छा, ये भी तो डायरेक्शन कोसाइन का फॉर्मूला है, दैट इज L इक्वल टू कॉस अल्फा, M इज इक्वल टू कॉस बीटा, N इज इक्वल टू कॉस गामा. ये थर्ड पॉइंट में भी डायरेक्शन कोसाइन के बारे में ही बोला गया. दैट मींस डायरेक्शन कोसाइन्स ऑफ ए लाइन पासिंग थ्रू 2 पॉइंट्स. हाउ कैन वी फाइंड a डायरेक्शन कोसाइन ऑफ a line passing through the 2 given points? Suppose P and Q, let us consider the coordinates of PB x1, y1, z1, whereas the coordinates of QB x2, y2, z2. Then how can we find the direction cosines whenever 2 points will be given? The formula is direction cosines of this line. Direction cosines of this line PQ are x2 minus x1 by PQ, comma y2 minus y1 by PQ, comma z2 minus z1 by PQ. This is the formula. Okay, whenever 2 points will be given, then how can we find the direction cosines? By using this formula, x2 minus x1 by PQ, comma y2 minus y1 by PQ, comma z2 minus z1 by PQ. Now what is PQ? What is PQ? Where PQ is equal to the distance between the 2 points. That means under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is PQ. Okay, 2 points will be given in the question. P and Q का coordinates question में दिया रहेगा. Okay, by using these 2 coordinates, you have to find the direction cosines by using this formula. Okay, what is PQ? Distance between the 2 points. Okay, so this is all about direction cosines of a line passing through 2 points. अभी जो ये मैं 3 points discuss किया, ये 3 points का एक एग्जांपल मैं देने जा रहा हूं. फर्स्ट पॉइंट क्या था? डायरेक्शन कोसाइन. दैट मींस L इक्वल टू कॉस अल्फा, M इक्वल टू कॉस बीटा, N इक्वल टू कॉस गामा. नाउ व्हिच फॉर्मूला, when we have to use which formula? ये भी डायरेक्शन कोसाइन का फॉर्मूला है, ये भी डायरेक्शन कोसाइन का फॉर्मूला है, राइट? जब एंगल दिया रहेगा, then always you have to use this formula because alpha, beta and gamma are what? Directed angles. Okay, so for example, if a line makes angles 90 degree, 135 degree and 45 degree with x, y and z axis respectively, find the direction cosines. Okay, whenever the angles will be given, then you have to use the first formula because alpha, beta and gamma का value दिया हुआ है. This is not like x1, y1, z1, x2, y2, z2, right? So if a line makes an angles alpha, beta, that is 90 degree, 135 degree and 45 degree with x, y and z axis, then find the direction cosines. How can we find direction cosines? Since the directed line makes angle 90 degree with x axis, that means we can say that here alpha is equal to 90 degree, beta is equal to 135 degree, gamma is equal to 45 degree. So let us find now LMN. So L equal to what? L is equal to cos alpha. That means cos 90 degree. We know cos 0 is 1. So cos 90, 0. M is equal to cos 135 degree. And the value of cos 135 is minus 1 by root 2. N is equal to cos 45 degree. And the value of cos 45 degree is 1 by root 2. Okay. So these are the direction cosines. 0, minus 1 by root 2 and 1 by root 2. So whenever angles will be given, then you have to use the first formula. But whenever the 2 points will be given, then we can find the direction cosine by using the second formula. That is x2 minus x1 by PQ, y2 minus y1 by pq, comma z2 minus z1 by pq, where pq is equal to the distance between the 2 points. Okay, so ये हो गया फर्स्ट 3 पॉइंट्स का डिस्कशन. एग्जाम्पल भी दे दिया, सबको क्लियर होना चाहिए. नाउ द फोर्थ पॉइंट इज, व्हाट इज द फोर्थ पॉइंट हियर? डायरेक्शन रेशियोज. सो डायरेक्शन रेशियोज क्या है? Direction ratios are nothing but the numbers, any 3 numbers, and direction ratios are denoted by A, B, C, small letter A, B, C, whereas direction cosines are denoted by L, M, N. So direction ratios means what? Any 3 numbers. तो ये इसके बारे में तो ज्यादा कुछ नहीं बोलना है, एक्चुअली फॉर्मूला क्या यूज करना है वो उसके लिए मैं ये पॉइंट लिखा. ठीक है. So since direction ratios are denoted by A, B, C, sometimes the questions will be like this. Direction ratios will be given in the question and you may ask that how to find the direction cosine. So from direction ratios how can we find direction cosines? वो फॉर्मूला बताने के लिए मैं ये सब टॉपिक लिखा है. ठीक है. Since direction cosines are denoted by L, M, N, so whenever direction ratios will be given and you are asked to find the direction cosine, then by using this formula, now I am writing the formula, L is equal to plus minus A by under root A square plus B square plus C square. M is equal to B by under root A square plus B square plus C square, and N is equal to plus minus C by under root A square plus B square plus C square. ये हो गया फॉर्मूला. जब डायरेक्शन रेशियोज दिया रहता है, then by using this formula we can find direction cosine. चलो डायरेक्शन कोसाइन का और एक फॉर्मूला मिल गया. जब एंगल दिया रहता है you have to use cos alpha, cos beta, cos gamma. जब दो पॉइंट्स दिया रहेगा then you have to use the second formula, that is x2 minus x1 by pq, comma y2 minus y1 by pq, comma z2 minus z1 by pq. Whenever the direction ratios will be given, that means any 3 numbers. Direction ratios are nothing but any 3 numbers. So whenever any 3 numbers will be given, then by using these results we can find the direction cosines. Okay, here I have given plus minus sign. So plus minus sign का मतलब है either you have to use plus sign or you have to use minus sign. इस एक में प्लस एक में माइनस ऐसा नहीं है. अगर प्लस यूज करना है तो तीनों में प्लस यूज करना है, माइनस साइन यूज करना है तो तीनों में माइनस साइन यूज करना है. ओके, सो दिस इज ऑल अबाउट डायरेक्शन रेशियोज, एनी 3 नंबर्स. सो द नेक्स्ट पॉइंट इज डायरेक्शन रेशियोज ऑफ ए लाइन पासिंग थ्रू 2 पॉइंट्स. अभी डायरेक्शन रेशियो कैसे फाइंड आउट करना है जब 2 पॉइंट दिया रहता है. व्हेनेवर 2 पॉइंट्स विल बी गिवन, तो मैं तो डायरेक्शन कोसाइन के बारे में बताया, अभी डायरेक्शन रेशियोज कैसे फाइंड आउट करना है वो मैं बताऊंगा. व्हेनेवर 2 पॉइंट्स विल बी गिवन. Suppose there are 2 points P and Q whose coordinates are given, and we all know we can draw only a line by using the 2 points. Yes? So, how can we find the direction ratios by using these 2 points? Very simple. Whenever 2 points will be given, the direction ratios are x2 minus x1, x2 minus x1, comma y2 minus y1 and z2 minus z1. बस और कुछ नहीं. जैसे डायरेक्शन कोसाइन के लिए फॉर्मूला में लिखा था x2 minus x1 by pq, so here no need to write the denominator part. Okay, so numerator part लिखने से हो जाता है. That is x2 minus x1, comma y2 minus y1, comma z2 minus z1. Whenever the 2 points will be given, by using this formula we can find direction ratios. Okay, so x2 minus x1 करने से एक रियल नंबर मिलेगा, y2 minus y1 करने से भी एक रियल नंबर मिलेगा. सिमिलरली z2 minus z1 कैलकुलेट करने से भी रियल नंबर मिलेगा. सो डायरेक्शन रेशियोज आर नथिंग बट एनी 3 numbers which are denoted by a, b, c. So we can say that a equal to x2 minus x1, b is equal to y2 minus y1, and c is equal to z2 minus z1. Okay, and the last point is the last part, conditions for co-linearity of 3 points. So जब 3 पॉइंट दिया रहता है तो कोलिनियरिटी है कि नहीं वो कैसे चेक करना है. फर्स्ट ऑफ ऑल, व्हाट डू यू मीन बाय कोलिनियरिटी? कोलिनियरिटी ऑफ 3 पॉइंट्स का मतलब है whenever the 3 points lie on the same line, say A, B, C. Okay, let us consider the coordinates of A, B, x1, y1, z1. The coordinates of B, x2, y2, z2, and the coordinates of C, x3, y3, and z3. So condition for collinearity. ये जो 3 पॉइंट है, ये 3 पॉइंट एक ही लाइन में है. सो वी कैन से दैट द 3 पॉइंट्स आर कोलिनियर. बट न्यूमेरिकली जब सॉल्व करना है तो कैसे चेक करना है, कैसे पता चलेगा कि वेदर द 3 पॉइंट्स आर कोलिनियर और नॉट. द कंडीशन इज, सपोज देयर आर 3 पॉइंट्स. Whenever 3 points will be given and you are asked to check the collinearity, first find the direction ratios of AB and then find the direction ratios of BC. Find the direction ratios of AB and then find the direction ratios of BC. If the direction ratios are proportional, if the direction ratios of AB proportional to direction ratios of BC, then only we can say that the 3 points are collinear. Okay, बहुत आसान है. First find out the direction ratios of AB. How can we find direction ratios of AB? x2 minus x1, y2 minus y1, z2 minus z1. Similarly, you have to find the direction ratios of BC. x3 minus x2, y3 minus y2, z3 minus z2. And after that, you have to check whether the direction ratios of AB proportional to direction ratios of BC or not. It is almost like जो वेक्टर अलजेब्रा में किया था, that is b bar is equal to lambda into a bar. वही वैसा टाइप का ही है. ठीक है, प्रोपोर्शन कैसे होगा, कुछ एक कांस्टेंट रहेगा, स्केलर क्वांटिटी, उसके ऊपर बेस करके पता चल जाएगा whether the 3 points are collinear or not. Now I will give one example. Let us take one example. Show that the points, say A2, 3, minus 4, B 1, minus 2, 3, and C, and the coordinate of C be say 3, 8, minus 11. So these 3 points are given. You have to check that, show that the 3 points are collinear. So मैं क्या बोला था, यहाँ पे कुछ मेंशन नहीं किया whether by using the concept of vector algebra or 3D geometry you have to show. You can use any concept. Okay, so already vector algebra का concept तो पता है. So अभी 3D geometry का concept use करके कैसे solve करना है. So क्या है first step? First find out the direction ratios of AB. So let us find the direction ratios of AB. So direction ratios of AB are x2 minus x1, right? So 1 minus 2, that is minus 1. y2 minus y1, that is minus 2 minus 3 is minus 5. z2 minus z1, z2 minus z1, that means 7. z2 minus z1. Yeah. Then similarly find the direction ratios of BC. x3 minus, that is 3 minus 1 is 2. 8 plus 2, that is 10. Minus 11 minus 3 is minus 14. Now you have to check whether the direction ratios of AB are proportional to the direction ratios of BC or not. So therefore, direction ratios of AB proportional means that is AB by BC. Check करने से क्या मिलेगा? Direction ratios of AB. What are the relations? So the relation between AB and BC are, you can check the there is a whether they are proportional or not. Minus 1 by 2, yes. Comma minus 1 by 2, yes. Comma minus 1 by 2. मतलब actually क्या check करना है? Let the direction ratios of AB be A1, B1, C1, whereas the direction ratios of BC say A2, B2, C2. Okay? Then if A1 by A2 is equal to B1 by B2 is equal to अगर C1 by C2 हुआ तो then only we can say that the 3 points are collinear. So A1 by A2 minus 1 by 2 मिल गया. B1 by B2 करने से भी minus 1 by 2 आएगा. C1 by C2 करने से भी minus 1 by 2 आएगा. Actually the condition is this one only. Okay, A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Proportional means this is the condition. Okay, so that means we can say that here direction ratios of ABE proportional to the direction ratios of BC. So that means we can say that the 3 points A, B, C are collinear. Okay, so this is the example of collinearity. So ये सब जो था ये एकदम basic part था 3D geometry का. In the next class I will start the main part of 3D geometry. Actually 3D geometry is divided into 2 parts, that is line and plane. So in the next class I will discuss line, straight line part. Okay, so these are all the basic parts. Once you go through all these basic parts, then you can easily able to solve the questions, basic questions. I will give some questions also in the next class. Okay, thank you for today.